Hello, everyone. Welcome. My name is Elena Martinez, and I'm the technical manager for this session entitled Using the MAPS tool to monitor the cost and cost effectiveness of food systems interventions, economic evaluations for non-economists. This session will be chaired by Katie Adams from the University of California, Davis, who's joined by several members of the MAPS team. So we have a lot of expertise with us here today. Thank you so much for taking part in ANH 2024. We look forward to a robust and interactive session today. And a quick reminder that the conference program and materials can be found on our website. I have a few technical announcements before we get started. So first, this session will be recorded and posted on the ANH Academy website following the conference. You've all been muted as you enter the session, but please introduce yourselves in the chat function. You can let us know your name, where you're joining us from, and the organization you work with. If possible, we encourage you to turn on your video during the session, but if your connection is bad, then you can turn off your video. If you have any questions, please share them in the chat box throughout the session. And last, if you do experience any technical issues, we encourage you to check your audio and video settings. You can also direct message me or anyone with ANH Academy in their Zoom name, and we'll help you troubleshoot. And finally, we do ask that you not use AI bots to take notes or record the session. We will be recording the session and sharing it on our website following the conference. So thank you so much, and I'm going to pass it over to Katie Adams to get the session started.
Great, thanks very much. I'm going to go ahead and share my screen. Okay, so thanks very much to everyone for joining us for this ANH Academy virtual learning lab session that's all about using the MAPS tool to model the cost and cost effectiveness of food systems interventions. My name is Katie Adams. I'm an economist but work as a researcher with the Institute for Global Nutrition at University of California, Davis. And we've designed this learning lab session to try and help make economic analyses of health or nutrition interventions more accessible to non-economists, both in terms of understanding and interpreting results from different types of economic analyses, but also in terms of actually undertaking rigorous economic evaluations. The MAPS tool, which we'll be exploring and using together during our session, was designed in part to enable and empower you to kind of undertake cost-effective analysis. So I hope you find today's session a kind of a productive use of your time. We have a large group of participants joining us today, so introducing everyone one by one orally would take up most of our time. But I do want you to be aware that we have a number of MAPS team members with us here today, all of whom who've made critical contributions to the development of the MAPS tool in different ways. And today they'll be helping manage the session, answering questions, et cetera. And I'm really thankful to have them joining us today. A bit of housekeeping here to help make our session run smoothly. If you're having any technical issues with the Zoom session, like you can't hear or you can't raise your hand, enter the issue into the chat box and an ANH support person will help address that. My solution with Zoom is always to just leave the call and rejoin as a first try, and that seems to work more often than not, so you might give that a try. If you have MAPS related questions during the session, like you're having trouble completing a specific task, or you don't understand a particular bit of output, or something along those lines, you can either raise your hand, and depending on where we are in the flow of the session, we'll be able to answer your question orally, or you can type your question into chat and a MAPS team member will answer it. And then finally, if you have feedback either on the MAPS tool or today's session itself, and we very much welcome any and all feedback, as it really helps us improve the tool and how we design these types of sessions. You can either type your feedback into the chat or save it until the end of today's session, because there'll be a chance for you to relay all of your feedback to us at the end of the session via an interactive platform called Slido. Slido is a platform that allows participants in meetings to take polls and surveys, enter feedback, etc. And we'll be using this platform several times today. You can use Slido without a user account by going to slido.com and entering this ID code that you can see on the screen here. And we'll also put it in the chat now, or you can scan a QR code that you'll see on the next screen. All of the responses and feedback that you provide via Slido today will be entered and stored anonymously. But if you have any worries about using Slido, you can let us know. And of course, participation in these types of polls is purely voluntary, so you can skip those if you would rather not participate. I'd like to now take just a few minutes to get to know all of you a bit. There are 3 poll questions that you can find via Slido. So if everyone would take just a few minutes to go to slido.com and enter the code that's shown here or that's in the chat, or by scanning the QR code, you should be taken straight to the polls, and then we can view the results. Great. I see that some people are already responding to the polls. Okay, I see less activity on the poll now, so I think we can kind of look at those results. So it looks like most of the participants today are in academia, some are with research organizations, and other with kind of aid organizations or NGOs. Most people are working in nutrition, some working in public health. We have people in agriculture, and a couple of people joining who work in economics or finance, which is great. We have a diverse group with us. And then in terms of whether or not people have ever used economic analyses in their own work, a big majority say no, but they would like to. And that's exactly what kind of who we were hoping would join. So people who haven't necessarily had a lot of experience with it, but are interested in learning more and learning about the MAPS tool to do that. Great, thanks everyone. I want to provide just a quick overview of what we'll be covering in this learning lab. We'll begin by reviewing the learning objectives for the session, just to get us all on the same page about what we're trying to accomplish. Then I'll provide a brief introduction to MAPS and the MAPS tool. Next, we'll spend some time discussing kind of the what and why of economic evaluations for nutrition or food systems intervention, so that everyone knows what's meant by cost effectiveness versus cost utility versus cost benefit. Then I'll spend a few minutes describing the methodology used in the MAPS tool to estimate costs effectiveness and cost effectiveness before moving into the main part of today's session, which is a case study designed to gain experience for you on how to use the cost effectiveness module of the MAPS tool to undertake an economic evaluation. After that, we'll do some thinking as a group about how you might use the MAP tool in your own work or research, or to answer policy questions in your country context. And then finally, you'll have the opportunity to provide feedback on both today's session and the MAPS tool itself. There are 4 main learning objectives for today. The first learning objective is to understand the purpose of undertaking an economic evaluation and to be able to distinguish between different types of economic evaluations. So, what do people mean when they say something is cost effective versus something has a high cost benefit ratio? The second learning objective is to become familiar with the cost effectiveness functionality of the MAPS tool, and to begin to build confidence using the tool to predict the impacts of food systems interventions on the micronutrient adequacy of diets. Third, we hope that you gain experience and confidence, enough experience and confidence to collaborate with economists to use the MAPS tool, the MAPS tool, the cost modeling framework, to generate estimates of the cost of micronutrient interventions in your context. And then finally, we hope you leave today's learning lab with a sense of how economic evaluations can be used to inform decision-making around the selection and design of effective and efficient food systems interventions, and also importantly, to understand the limitations of economic evaluations for decision-making. Now, moving into a brief introduction to the MAPS project and the MAPS tool itself. So MAPS stands for Micronutrient Action Policy Support. The MAPS project began around 2020 and is funded by the Bill and Melinda Gates Foundation. MAPS is a collaborative project led by the University of Nottingham, but with quite a few collaborating institutions, including the Lilongwe University of Agriculture and Natural Resources in Malawi, Addis Ababa University in Ethiopia, and University of Ibadan in Nigeria. The overall objective of the project has been to co-create a web-hosted tool that enables both national and subnational estimates of micronutrient inadequacies and/or deficiencies, as well as facilitate exploration of pathways to improve the micronutrient adequacy of diets in Africa. And as the MAPS project has developed the MAPS tool, applying this kind of concept of co-design has been fundamental to the approach we've taken, which means we've developed the tool collaboratively and in an iterative process with stakeholders and end users, including international stakeholders and also very critically national level stakeholders in nutrition and agriculture. And the aim of this kind of iterative co-design process is that at the end of the day, we hope that we've developed a tool that meets currently unmet needs of users and facilitates user-driven interaction with and modeling of micronutrient data. Also, the MAPS tool development and outputs are fully open access, so the scripts underlying the tool are available on GitHub, and the estimates made within the tool itself by users can be downloaded by users. And then finally, the tool will have a bring your own data functionality. So in contexts where data sets are not preloaded, or if in the future new data becomes available that the user would like to analyze or visualize with using the MAPS tool, they'll be able to essentially bring that data securely and, if desired, privately into the tool. Right now, the MAPS tool has two main live modules, Quick Maps and the cost effectiveness module. I'm going to right now provide a very quick walkthrough of Quick Maps. You're welcome to follow along in the tool yourself as I go through this. The link to the tool is here, and we'll also have it in the chat. And I should also note that the tool is not optimized for use on phones or small tablets. So if it's possible, it's best if you can use the tool on a PC or a laptop. So I'm going to click into the tool right now. So this is kind of the home page of the MAPS tool. And I'm going to click on the MAPS tool portal here and then scroll down to Quick Maps. And you'll see that we have a disclaimer that this is kind of an early release version of the tool for user testing and feedback. And at this point, we really don't recommend people using the tool to make decisions, but soon the tool will be at a point where we feel like it's ready for use, but right now it's in kind of a user testing phase. So this is the Quick Maps page. For some countries, the Quick Maps is preloaded with household consumption and expenditure survey data. That's a handful of countries. And for the rest of the countries in Africa, it's preloaded with food balance sheet data. So if I choose, for example, let's choose Nigeria, which I know has household consumption and expenditure survey data loaded, and say I'm interested in looking at the supply of, let's say, iron in Nigeria. We're going to use food systems data, and this here shows that I'm using the 2018-2019 Nigeria Living Standards Survey data. And then I can view the results. It takes a few seconds for the data to be loaded. But in the meantime, up in the kind of top, you can see information about, what proportion of foods in the food list were matched with different food composition tables. And you can get kind of an estimate of the apparent intake of iron per adult female equivalent based on the household consumption and expenditure survey data relative to the adequacy threshold for an adult female equivalent. Okay, so the data have loaded now, and you can look at a number of different things in Quick Maps. Let me open this box. So for example, at the state level in Nigeria, you can get estimates of apparent intake of iron per adult female equivalent, the mean or median there. You can also look at variation from the adequacy threshold. So you can see in some states, this is 81% of households have inadequate supply of iron to meet the requirements of an adult female. But there's a lot of variation across states. So in some states, it's 29%. You can also use Quick Maps to look at the main dietary sources of iron or whichever micronutrient you're looking at in the diet. So here we can see tilapia, sorghum, beans are kind of the main contributors to iron intake in diets. You can look at this from the food group perspective too. Again, seeing sorghum, freshwater fish, and beans providing most of the iron in diets in Nigeria. We're also able to look at kind of seasonality in iron intake here. So if I pop this box open, We can look at how the sources of iron vary across months. And you can see for iron, actually, there's not a lot of variation in the primary sources of the foods that are contributing to iron intake across the year. So again, it's kind of sorghum, fish, and beans across most of the months of the year. And then in the bottom box, you can look at kind of a histogram of apparent intake of iron relative to the threshold. Now, if I were to choose a country that does not have HCES data loaded, but instead is loaded with food balance sheet data, so say I choose Rwanda, and we want to look at the supply of vitamin A in the food system. Here, of course, food balance sheet data are not at the household level, so we just have kind of one estimate at the national level, but you can see, relative to the adequacy threshold for vitamin A, the availability of vitamin A in the food supply in Rwanda is estimated to be quite a bit lower than the adequacy threshold. You see that here. And then also, again, we can look at the main sources of vitamin A in the diet. Pop this box up, which are mainly coming from mangoes, milk, tomatoes, etc. in Rwanda. So that's a quick introduction to Quick Maps. I'm going to come back to the slideshow now. For the remainder of today's session, we're going to be focusing on the other module of the tool that's live, the cost effectiveness module. So at kind of a high level, the cost effectiveness module is designed to use detailed cost models in conjunction with modeled household food consumption data to estimate and compare the impacts, cost, and cost effectiveness of existing and hypothetical food systems interventions for improving the micronutrient adequacy of diets. And the food systems interventions available in the tool will be large-scale food fortification. So for example, refined oil fortified with vitamin A or wheat flour fortified with iron and folic acid. Biofortification, so this would be orange flesh sweet potato, iron beans, things like that. And then agronomic biofortification, which is increasing the micronutrient content of the edible portion of crops via enhancing fertilizers with micronutrients that are applied either as granular fertilizers or as foliar sprays to the crops. And what we're trying to achieve with the cost effectiveness module of the MAPS tool is first to provide a collection of comprehensive cost models that enable users to estimate the cost of micronutrient interventions. And in doing so, we are pre-populating those cost models with the best available primary and secondary data. We are ensuring that we're transparent about data sources and methodology. And we've built a user interface that we hope encourages users to really engage with the cost data and modify cost model inputs so that the cost estimates ultimately reflect the reality in their context. We're also seeking to provide a framework to model the impacts or effectiveness of food systems interventions on the micronutrient adequacy of diets at the household level. And ultimately, we provide a framework for combining the cost and impact estimates so that users can estimate and compare the cost effectiveness of different food systems interventions on the micronutrient adequacy of diets. Before we dive into the cost effectiveness module itself, I want to take just a few minutes to talk through the kind of the what and why of economic evaluations for nutrition or food systems intervention. So when someone says something is cost effective, what do they really mean? And why should we care about things like cost effectiveness when making policy decisions or deciding to invest in one intervention over another? Cost effectiveness is just one of several different types of economic analyses that can be conducted to compare the cost of an intervention to its impacts. And starting with kind of the basis of every economic analysis, a cost analysis provides an estimate of the total cost of a program, intervention, or policy at a specific scale. And because an estimate of the total cost is not standardized, in any way, it's difficult to compare costs across contexts. And of course, it also doesn't link cost to specific health or nutrition outcomes. But as I said, it does form the basis of any economic analysis, and therefore, a really high quality economic analysis depends on a rigorous estimate of the total cost of an intervention. As an example of the result of a cost analysis, an ex-ante study estimated that the cost of enriching maize, rice, and wheat with zinc via foliar spraying in Zambia would be somewhere around $1.8 to $2.7 million per year. Next is cost efficiency, and most cost analyses also calculate some measure of cost efficiency or the cost per unit of output. So for example, cost per capita or cost per person reached or per beneficiary, cost per metric ton of a fortified food, or cost per hectare of biofortified crop. And like total cost, this does not link cost to specific health or nutrition outcomes, but it does help make it possible to make more direct comparisons across different contexts, or as in this example, for example, across different food vehicles. So in a study in Uganda, they estimated that the cost of vitamin A fortification is around $5.29 per metric ton of refined oil, while it's around $11.39 per metric ton of sugar. Now, if the impacts of an intervention or a policy are also measured alongside costs, this opens up several additional types of economic analyses, the first being cost effectiveness, which provides an estimate of the cost per unit of outcome, where the outcome is measured in natural units. So things like the number of people achieving dietary micronutrient adequacy as the result of an intervention, or it could be more functional outcomes like cases of anemia averted or deaths averted. So as an example, one study found that the cost per case year of maternal anemia averted via wheat flour fortification was $2.20 in urban Cameroon. One thing to keep in mind about cost effectiveness analysis is that it requires identifying a single impact and comparing it to the value of all the resources required to kind of provide and or access that intervention. So if an intervention has more than one impact, say it averts both deficiency and death, you either need to calculate two separate cost effectiveness estimates, or you need to use another type of economic analyses like cost utility that combines impacts. So cost utility analysis is actually quite often referred to as cost effectiveness analysis, and I think we can think of it just as a kind of a specific type of cost effectiveness analysis. But what distinguishes cost utility from cost effectiveness is that impacts or effects are translated into disability adjusted life years averted or quality adjusted life years gained, meaning that if an intervention has several impacts that can be translated to, say, DALYs, using an established weighting system, such as the disability weights that are used in the global burden of disease, then all of those impacts can be summarized in one cost utility measure, being cost per DALY averted. One note here is that some impacts or outcomes may not have established disability weights, so it may be difficult to include those in the total DALYs averted estimate. As an example of this type of estimate, a study by Harvest Plus found that an orange flesh sweet potato intervention in Uganda is estimated to cost around $15 to $20 per DALY averted. And then the final category is cost benefit analysis. Here, all of the impacts of an intervention are converted to a monetary value, which then allows for an evaluation of whether the intervention's benefits exceed its cost, which would be a benefit cost ratio greater than 1. As well as it allows for comparisons of across interventions that have very different sets of goals or impacts. One consideration when using this approach is that many interventions have a very wide array of impacts, many of which don't have like a market price or an obvious social value weight, making the task of translating impacts into monetized benefits potentially complex and controversial. So for example, what's the value of a life saved? Is the value of a child's life different than the value of an adult's life? There are methods to place a dollar value on life, but as you can imagine, it's definitely not a straightforward conversion. And then as an example of cost benefit, this is the result of a study that used a cost benefit framework in the context of double fortified salt in India And they estimated that universal distribution of double fortified salt could achieve a benefit cost ratio of 4.2, meaning that for every dollar invested, the discounted return would be $4. So in MAPS, we currently focus on cost effectiveness. And of course, as inputs into cost effectiveness, we also calculate total costs and cost efficiency. Okay, so now that we kind of all know what economic analyses are, what cost effectiveness is, let's also quickly discuss why we might want to conduct costing and cost effectiveness analysis or some other type of economic evaluation. That is, so for food systems interventions, why is it important to put the evidence of efficacy or effectiveness, or say modeling results showing an impact on, the impact of intervention on micronutrient adequacy? Why is it important to put that in the context of costs to achieve those impacts? Well, first, policymakers and decision makers in low and middle income country contexts generally operate in highly resource constrained decision spaces. So although it would be nice to be able to invest in all nutrition interventions with good evidence of public health benefit, efficacy and effectiveness of an intervention does not imply financial feasibility. Given that, it's important for decisions about what interventions to invest in and where to be guided not only by evidence of effectiveness, but also by how the costs of alternative interventions compare. And cost effectiveness provides a framework for data-driven prioritization of interventions. It can also help inform discussions around financial feasibility and help policymakers decide the most efficient way to meet their policy objectives within the bounds of their resource constraints. At the same time, I think it's also extremely important to be aware of the limitations of cost effectiveness analysis as input into decision making. So some of the key limitations I want to highlight today are first that cost effectiveness does not directly consider equity. So an intervention might be quite cost effective, but not, for example, do a good job meeting the micronutrient requirements of the poorest segment of a population, or it may inequitably reach men over women, things like that. Cost effectiveness can be considered alongside evidence of impact that's specifically tailored to consider equity dimensions of interventions, but this is not currently something that's typically built into cost effectiveness analysis. So this is something to think about if equity is an important policy objective. It's also important to always keep in mind that estimates of cost effectiveness are context specific. I'm sure, for example, many of you have seen this kind of universal claim that large-scale food fortification is cost-effective. And while this is certainly true in many contexts, it really depends. It really depends on carefully choosing an appropriate food vehicle to fortify, carefully setting fortification levels that will help close the micronutrient gap, the size of which is context specific, and implementing and maintaining strong monitoring and evaluation systems to enforce fortification standards. So, just because a specific intervention is cost effective in one context doesn't mean it's necessarily cost effective in another context. So conducting these context specific analyses is important. Another important limitation is that cost effectiveness does not imply affordability. And it's always important to think about which stakeholder groups will be called upon to pay which costs and what will be affordable to these different stakeholder groups. If you have what you think is a very low cost intervention because most of the costs will be passed on to, say, farmers or to consumers, but those costs aren't affordable to farmers or to consumers, farmers won't adopt, or consumers may not purchase and consume what you're hoping that they will. So thinking about societal cost to all stakeholder groups is an important, it's important to think about alongside thinking about cost effectiveness. And then finally, when conducting a cost effectiveness analysis, the results are only going to be as good as the data used to generate them. So not only is it important to be aware of uncertainties in the underlying data, but it's also important to conduct sensitivity analysis around particularly uncertain or particularly influential parameter values, both on the cost and impact or effectiveness side of the equation. Okay, a couple of notes on MAP's cost effectiveness methods before we get started on exploring the cost effectiveness module and working through the case study. So starting with how we estimate costs, we take what's called an activity and ingredients-based approach or a microcosting approach to developing the cost models, meaning that for each intervention type, so large-scale food fortification, biofortification, and agronomic biofortification, we have defined a series of activities required to undertake the intervention from startup to scale up through annual operating activities. And then for each activity, we identified the types and quantities of inputs or ingredients that are required to execute that activity. So things like equipment and supplies or personnel, etc. And then the assumptions and unit cost estimates that go into actually parameterizing these activity-based cost models come from both secondary data sources, so perhaps unit costs published in the literature or the UNICEF supply catalog. We could get things like the price of an eye check device, as well as primary data collection in the countries. And we've defined intervention costs from a societal perspective, meaning that all costs are included regardless of who incurs them. So whether they be government or public sector costs, industry costs, or private costs, for example, costs that could be passed on to consumers of fortified foods. We've modeled costs over a 10-year time horizon. And what this does is allows for interventions that are totally new or not performing well in terms of, say, compliance with a national standard or farmer adoption rates. It allows those interventions to have several years of startup or scale-up costs without a lot going on in terms of the nutritional impacts or changes in those impacts. But then once they're up to scale, they can be compared to interventions that are already in place that are operating at scale. And then finally, we have very intentionally developed a core set of default cost model templates that have a consistent structure and set of activities. And then the idea is to make them country specific by modifying program assumptions, unit costs, and things like that without having to start from scratch and build a new cost model each time you want to, say, add a new intervention, add a new food vehicle, add a new crop, add a new country, etc. So right now we have a series of LSFF biofortification and agronomic biofortification cost models pre-populated with primary and secondary data for just Malawi and Ethiopia. But the cost modeling templates, which again were designed to be flexible and adaptable, are available offline in Excel and then within the tool itself for use in other countries. But of course, using them will require some data collection. In terms of effectiveness modeling, the methodology for estimating effectiveness in the MAPS tool is based on the concept of effective coverage, which is basically the change in the prevalence of inadequate micronutrient intake from diets alone compared to that prevalence with a micronutrient intervention or a set of interventions. We model this change using food consumption data from household consumption and expenditure surveys, matched with nutrient values from locally relevant food composition tables to estimate a baseline prevalence of inadequacy. And then we model the contributions from micronutrient interventions by identifying quantities of fortifiable or biofortifiable foods consumed by the household and increasing the micronutrient content of those foods based on, for example, fortification standards or expected micronutrient contents of biofortified foods. Baseline adequacy and adequacy with an intervention are assessed relative to the needs of a non-pregnant, non-lactating adult female or the adult female equivalent. And within the tool, the user has the option to assess adequacy based on either the apparent intake method or the nutrient density method, where the former is apparent intake per adult female equivalent and compares that to the nutrient requirements of an adult female, while the nutrient density method looks at the nutrient density of the household diet and compares it to the critical nutrient density of an adult female. Within the tool, the user can calculate and display a number of different metrics related to the effectiveness of an intervention at the national level, by subnational geography, so region or district or state, by urban and rural residents, and by household socioeconomic status. including the baseline prevalence of micronutrient inadequacy, the reach and apparent consumption of fortifiable or biofortifiable food vehicles, the change in the prevalence of inadequacy with an intervention, or what we call effective coverage, and then where relevant, also the prevalence of estimated intake above the tolerable upper intake level. And then if the user has defined both costs and effective coverage, the cost effectiveness of an intervention is measured as the cost per household effectively covered, calculated as a 10-year sum of total costs divided by this 10-year sum of households effectively covered. Final thing to just very quickly mention before we go into the tool is that the cost effectiveness module is still very much in a kind of limited beta version. And you'll see that you'll only be able to model interventions from Malawi. The intervention choices are limited to LSFF for food fortification, and the food vehicle choices are limited. The module is also currently undergoing testing of calculations and functionalities, and the effectiveness component is literally hot off the press. And as a result, we are still in the process of making some improvements to things like how the user flows through the module. So kind of your understanding regarding kind of the very early release nature of this module is appreciated. Soon, methods and data sources will be kind of more thoroughly documented, and there will be help and tip buttons displayed on each page. You'll be able to choose among multiple countries. You'll be able to model, the full scope of interventions, LSFF, biofortification, and agronomic biofortification. And you'll be able to model existing or hypothetical interventions, so that the breadth of what you'll be able to model will expand drastically. Related, there are several planned functionalities that are still under development and are not part of the current release of the module, including a user interface to directly compare cost effectiveness and cost effectiveness across multiple interventions, the ability to combine the cost and impacts of multiple interventions, kind of layering of interventions. So in essence, being able to estimate kind of incremental contributions of adding a new intervention, changing the reference household member from the adult female to some other household member, and also incorporating sensitivity analysis. So with those caveats in mind, we're now going to spend a good chunk of time exploring the cost effectiveness module together by going through a case study. So everyone should have access to a Google Doc with step-by-step instructions for the case study, but I'm also going to be working through the case study with you on my screen. In terms of like how to best set this up, I think you might want to open the Maps tool in a browser window, and we can put the link again into the chat. Open the case study in another browser window so that you can kind of toggle between the two if you want to. And then you may want to kind of reduce your Zoom window so that you can still see it, but that it's not blocking your view of the tool. So you can, get out of full screen mode if you need to by pressing escape and then double clicking on the icon on your taskbar to kind of minimize it so you can still see it. And I'll go very slowly through this. This is the part where people should, really feel free to ask a lot of questions in chat, raise your hand, and we'll try to answer questions as we work through these case studies. Okay, so I am going to open the tool again myself. Okay, so I'm going to give everyone just a minute or two to get set up, and then I'll start kind of walking through the case study. I'm hoping that everyone is kind of on the tool now. And if you're having trouble with the Google Doc with the case study, don't worry too much about. Yes, Louise. So if everyone is on kind of the Maps tool homepage, you can click on the Maps tool portal. This will take you to the page where we can link to the different modules. You need to scroll down a bit so you can see all the options, and then we're going to click on cost and effectiveness here and view it. And you'll see here again that it comes up with kind of a disclaimer that this is kind of a testing version. We don't recommend that it actually be used for decision making yet. This is the point where we really want users to test it out and provide feedback. You can close that window. And if at any time people can unmute and just say slow down or wait, and I'll stop where I am until people get caught up. So everyone should be on a page where you're asked to create a micronutrient intervention. And you're going to press the purple Create Intervention button. And that should bring up a box where you're able to define your intervention. So we're going to go through each of the steps in defining our intervention. We're going to select Malawi for our nation. You'll see, as I noted, all the choices are very limited here. Just for the purposes of this learning lab, later on, you'll have a much wider selection of choices. But right now, we're going to select Malawi. Focus micronutrient, we're going to scroll all the way down and select zinc. The type of intervention is large-scale food fortification. For a food vehicle, we're going to select wheat flour. Intervention status, this is an existing intervention. Malawi currently fortifies wheat flour with zinc. And then for nature of intervention, we're going to say status quo. So this is already an existing intervention. We're not going to model changes to it. And then you can give your intervention a name. It doesn't matter what you name it. So I'm going to name my Malawi wheat flour zinc. You can see I've gone through a number of trials here. You can give it whatever name you want. You can add an intervention description, but that's optional. And then once you've made all of these choices to define your intervention, at the bottom, you'll press this button to create your intervention. So once we've defined our intervention and have it created here, we're going to push the edit button to start reviewing all of the default parameter values and making changes to those as needed. So I'm going to push edit. Again, if people need more time, please don't hesitate to just unmute and let me know. Or if you have a question at any point, type it in the chat or raise your hand and we'll answer it. I'm going to push edit. And this brings up a user interface where on the left-hand side bar, we're going to go through a number of steps to kind of define different characteristics about the intervention. Then we're going to go through costs. Those are different steps there. We're going to go through effectiveness, and then we'll have cost effectiveness. So back to defining the kind of performance of this large-scale food fortification intervention. These are pre-populated with default values based on both primary and secondary data, but the user can modify any value that's in a box. So say I thought actually only half of wheat flour in Malawi is industrially processed and hence fortifiable. I could change this value to 50, and that will change the calculations within the model. If you make changes to any of the parameter values and you change your mind about those changes, you can always come to the bottom and reset to the default values. And that will bring it back to the original value, which was 100 here. It's not quite showing up, but it'll be 100. What I want you to take note of on this step is that the current wheat flour fortification standard for zinc in Malawi is 80 milligrams of zinc per kg of wheat flour. Now, in this case study, at the top of the case study, you'll see that I've kind of set this up as we're going to act as though we are policymakers in Malawi, and we're tasked with kind of reviewing you've been tasked with reviewing the current wheat flour fortification standard. And you know that given wheat flour consumption patterns in Malawi, that the mandated fortification level, which is 80 milligrams per kg, is actually below the current World Health Organization wheat flour fortification guidelines. So we're going to try to use the MAPS tool to investigate whether it might, what it might cost if the current wheat flour fortification standard were revised, and how the impact of the intervention on the micronutrient adequacy of diets could change, and whether it would improve the cost effectiveness of wheat flour fortification in Malawi. So we're going to go through this first in this as the status quo. So we're going to leave it at 80 milligrams per kg, but then we're going to go through it again, and we're going to change that value, and we're going to see if there's a difference in costs and effectiveness and cost effectiveness. You'll also see on this page that the other micronutrients included in the wheat flour standard are entered here. We're focusing on zinc. We're going to be assessing effectiveness and cost effectiveness relative to zinc, but you're also able to see the mandated fortification levels of other micronutrients. Also based on estimates of the proportion of wheat flour that's fortified to any extent based on testing and the average fortification level, we calculate average fortification levels relative to the standard. So something odd is going on for me here in those calculated values. So I'm going to just quickly redo mine to make sure my values are correct. But we basically reduce the mandated fortification level to account for, less than perfect compliance with the national standard. Okay. So after you've reviewed all of the information on this page, you've made changes that you want, and you're happy with it, you can push confirm and continue. This button down here on the bottom. This will take you to, we actually are in the process of merging these two steps, but for right now, this step is similar information, but it's looking across the 10-year time horizon. So for each year of our 10-year time horizon right now set to 2021 to 2030, we have basically the same information about the proportion of wheat flour that's industrially processed, for the percent of fortifiable wheat flour that's fortified to any extent, and average fortification level. And if, say you wanted to model a situation where you were investing in enhanced monitoring enforcement, and you think in a few years there'll be improvements in compliance with the standards, so that closer to like 80 or 90% would be the average fortification level relative to the standard. You could make those changes here, and that would be captured in the average fortification level calculations below. But for right now, I think we can just leave these parameter values as they are. And then we want to confirm and continue to costs. If you didn't want to model costs, you could just confirm and continue to effectiveness. But we're going to go through the whole thing from start to finish here, including costs and effectiveness, so that we can ultimately end at cost effectiveness. So I'm going to push confirm and continue to costs. Okay, so there are a bunch of steps to go through to estimate the cost of wheat flour fortification in Malawi. And this starts with reviewing and editing, where needed, industry information. So, how many industrial scale wheat flour mills are there in Malawi? How many milling days are there on average per year? What do mills do generally in terms of internal quality assurance, quality control? So are they conducting in-house quantitative or qualitative tests for different micronutrients in the wheat flour? So we have default values here based on interviews with industry, but the user can change any of these, and those will later change the way the total costs of, say, quality assurance and quality of control are calculated in this kind of recurring cost step. So you can take some time and review these parameter values, edit them if you want, or leave them as they are. And once you're happy with that, we can confirm and continue. And then we're going to go through a similar set of information, but this is characterizing like government monitoring information. So, you know, on average, how many mill inspections are they doing per mill per year? When they go to and do those mill inspections, are they collecting wheat flour samples and testing for different micronutrients? And if yes, on average, how many samples are they collecting per mill inspection? So here we're saying for vitamin iron and vitamin A. Also, you know, what's the government doing in terms of import monitoring? If this is relevant at ports of entry, are they checking samples and collecting samples of wheat flour? And then are they doing anything in terms of monitoring at markets or at households? So, you know, they have some sentinel sites or markets where they're making visits to, again, collect samples of wheat flour to test to ensure that the wheat flour is being fortified as expected. So just like with industry information, you can change parameter values here based on, you know, your information about what Malawi is doing. And then this will feed into our calculations of the government costs for monitoring the wheat flour fortification program in Malawi. I'll give you a couple seconds to just kind of review this information. You can change parameter values if you want, or if you're happy with the defaults, then we would confirm and continue. I'm going to remind everyone again, don't be shy to unmute if you want me to slow down or explain something better. Please don't be shy. Okay, now we're moving into the startup and scale-up costs. Because this is an existing intervention in Malawi and we're not changing anything about it in this specific scenario, these startup and scale-up costs are all set to 0 by default. We'll talk about this more when we change the standard, but here, these are kind of the different, so you see industry-related startup and scale-up costs, and you'll see certain activities that are marked by this kind of pencil icon, and you can click into any of those activities to view and edit the costs that go into the total cost of that specific activity. Now, right now, they're all set to 0, so it's not so relevant. But when we get to recurring costs, I'll show you the same thing. But just so you know, you can click into any one of these activities to see the kind of ingredients that go into making up the total cost of that particular activity, and you can make changes there, and those would be reflected in your kind of more aggregate level cost summaries here. So we have industry-related startup and scale-up costs, all set to 0 by default, which makes sense in this scenario, as well as government-related startup and scale-up costs, which are all set to 0. So let's confirm and continue to recurring costs, where there's a lot more going on each year of the intervention. Okay, so you can see that recurring costs are broken down into recurring premix costs, recurring industry-related fortification costs, and then government-related monitoring and management costs for the LSFF program in Malawi. And again, like before, you can kind of click into any of the activities that are marked by the pencil icon. So say we want, you know, we're looking at these kind of 5.6 million per year premix costs, and we want to know where that estimate came from, and maybe we don't fully agree with it and we want to change something, we can click on premix. So you can see we have an estimate of the cost of the premix per metric ton of wheat flour on the top line there. Then we have, you know, costs for shipping, value added tax, local transport and storage, etc. And so the user could go through each one of these costs and make changes as needed. For the premix cost, like per metric ton of the food vehicle, we also have a premix cost calculator. So If you want to click on open the premix calculator, you can do that, and you can see where that cost per metric ton of wheat flour comes from. So this page shows you for each of the micronutrients that are included in the wheat flour fortification standard in Malawi, what is the fortification level. As you can see, as we had set on that one of the first pages, for zinc, it's 80 milligrams per kg. We're not modeling any overage. Our compound is zinc oxide. The activity level, so the amount of zinc in zinc oxide, is about 80%. So it calculates the amount of zinc oxide you need to meet a fortification level of 80 milligrams per kg of wheat flour. And then we have a price, a default price of zinc oxide. The user could change that value if they wanted, and that would change the total cost of wheat flour fortification per metric ton. And then at the bottom here, you can see the cost of the premix per kg, and then the total cost of the premix per metric ton of wheat flour, and that's all calculated for you. If you're happy with those default values, you can just push confirm, or you could change prices, change activity levels, etc., based on your kind of knowledge of the local situation. And so I'm going to confirm that. Okay. And sometimes the pages take just a second to load. I think it's just working with a lot of data behind the scenes. So nothing to worry about there. And then I'm going to just confirm these premix costs. Again, you can go through and make edits as you wish. And then we would, recommend that the users go through each of these different activities and click into them and really take a look at what ingredients are making up each of them and make changes as necessary. So under fortification, for example, for the industry, we have an estimate of the full-time equivalents per mill for additional labor for fortification related activities. And we have an estimate of the average salary of those mill employees, which is then used to calculate total labor costs for production or premix related activities in the mills. These values are modifiable by the user, and we really encourage people to review all of them critically and make changes where it's necessary. And yeah, so here you can just kind of go down all of the different activities at both the industry level and the government level and make changes where needed. So here, for example, we're estimating that mill inspections, there's a cost for making the inspections. There's costs for reagents, for tests of iron or vitamin A, and all of these values depend on kind of what we entered previously in terms of the number of inspections that the government is making and how many samples they're testing per visit to the mills. So you can make changes in that information, or you can make additional changes here in terms of unit costs of things like that. Okay, I'm going to give people another minute or two to just kind of explore on this page, click into these things. You'll see at the bottom too, we've included impact evaluation costs. Right now, by default, these are all set to 0. We didn't have great data on how to allocate the cost of just say wheat flour to a big national impact evaluation, but users could certainly come in and change these to something that was non-zero, and those costs would then be reflected. Any questions so far that people want to ask out loud, or you can just keep asking in the chat. That's also totally fine. Or not even any questions in the chat. Everyone's just plugging along, understanding what's going on.
I think we've been able to solve the couple of problems with connecting. But if anybody is having problems, as Katie says, please do let us know, right? You can message, as I've said in the chat, you can message individually to one of us. Yeah, thank you.
Okay, so once the user, or once you're happy with all of these recurring costs, you would confirm and continue, and this will bring us to a cost summary. So this basically just summarizes all of the information we've previously reviewed and edited. We have both options for a quick summary and then a more detailed summary. On the quick summary, we just get kind of annual average costs, total 10-year costs, costs per year disaggregated by industry or government and premix, etc. Some of these aren't quite programmed in yet, but all of these will be non-zero soon. And then you can also look at a more kind of detailed summary of the costs per year in terms of startup and scale up costs and then recurring costs. And again, you can click in just to have a more detailed view of what's contributing to these total costs for each year of the intervention. And you also have the option of viewing these more detailed costs kind of in a graphical form if that's helpful. And obviously, premix makes up the lion's share of the total costs, as expected, of wheat flour fortification in Malawi. And then once you're happy with the cost summary, so if you see something in cost summary you're not happy with, you can always click back and go back to the cost information and make changes so that the summary cost information seems reasonable to you. But if you're happy with that, then you could move on to confirm and continue to effectiveness, where we'll be looking at kind of the impact of zinc fortified wheat flour on the adequacy of zinc in diets in Malawi. The first page here is less relevant for zinc, but for some of the micronutrients, particularly vitamins, between point of fortification and households, we would expect sometimes quite a bit of the micronutrient to be lost due to degradation when it's exposed to air or heat or light, or it's stored for a really long time. So on this page, the user would be able to view expected losses of the micronutrient, and soon this column of expected losses will be modifiable by the user. So we have some default values there, but if the user has a different value that they would like to use, they will enter that here, and then that would carry over to the kind of the average fortification level that's modeled in terms of diets compared to the average fortification level that's used for modeling costs. So this page will be dynamic eventually, but right now it's just static, so you can just confirm and continue. Same situation here. So for each of the 10 years of the time horizon, we need to get an estimate of the number of households. And what we've done, and these methods and data sources will be, specified. You can click on the kind of the question mark to get some information. It tells you basically that we've taken world population prospects projections of populations in Malawi over our 10-year time horizon. And then we've combined that with estimates of the population share of each of the subnational units. So here it's districts to get like an estimate of the population at the district level over each year of the 10-year time horizon. And then we've also incorporated estimates of household size at the district level. Those can come from DHS data or like the household consumption expenditure survey sometimes. And then we've basically just divided the population by the average household size to get an estimate of the projected number of households for each year of the 10-year time horizon. And again, I think this page right now is static, but it's something that we may let users modify if they had different data sources they wanted to use. That's something we're kind of thinking through. But right now, you can just look at the population projections and then confirm and continue. And then we come to the page that the user can review and edit nutrient requirements. So our reference household member right now is a non-pregnant, non-lactating adult female. As I mentioned, we're planning to probably introduce functionality where the user could change who the reference household member was. But right now it's the non-pregnant, non-lactating adult female. We've used by default the harmonized average requirement, so 10.2 milligrams per day of zinc for our adult female. But the user can also change those values if, say, they wanted to use something from EFSA or IOM or something to change those values, they could do so here. We have an estimate of the adult female's energy requirement. This is not important if you're using the apparent intake per AFE method, but if you're using the nutrient density method, it is important, as the household nutrient density and the adult female's critical nutrient density depends on the energy requirement. And then from those two values, we calculated critical nutrient density for the adult female. And then for zinc, we also have a tolerable upper intake level for the adult female and a critical upper level, which would be used for the nutrient density. So the user can view these values. If they're happy with them, just confirm, continue, or edit them as needed. So let's confirm and continue. And this is where we're going to, so right now behind the scenes, the scripts based on what we've specified previously in terms of average fortification levels and micronutrient requirements and numbers of households, etc. It's using the household consumption expenditure survey data in Malawi to estimate a number of different measures of and or related to effectiveness. So you can see in this effectiveness summary box, you can choose either apparent intake per AFE or household nutrient density. So you can review the results by either of those two methods. And then right now you can look at the results at the national level, which is Administrative Region 0, or by the district level. Eventually, you'll also have choices where you could look by urban and rural and by household socioeconomic status. Right now, it's just by geography, but soon we'll have additional options here and be able to look at these metrics across household wealth quintiles, etc. So here, what's displaying now is reach and apparent consumption of wheat flour. So 54% of households in Malawi reported that they consumed wheat flour or some kind of processed product containing wheat flour during the recall period, which in Malawi was, I believe, 7 days before the survey. And we have estimates of mean and median average apparent consumption of wheat flour among the households that reported consuming wheat flour. So 42 grams per day per adult female equivalent for the mean, and 23.8 grams for the median. Now, if we changed the display from level 0 to level 1, and we'll also, all of these data will also be visualizable in maps as well. Right now, we just have the tabular form, but soon you'll also be able to view them in maps, which will make kind of looking at differences across districts a lot easier, because there are a lot of districts in Malawi. But even just kind of glancing at these, you can see some pretty wide variation across districts in both reach and apparent consumption. So like in Lilongwe, for example, here, you can see, 3/4 of households reported consuming wheat flour, and Lilongwe's primarily urban, compared to Machinga, which is more rural. Only half of households there reported consuming it, and the quantities consumed are quite a bit lower. So just from that type of information, you can already tell that the impact of the intervention is going to vary spatially across Malawi. We can then look at micronutrient inadequacy. So we're working on the best way to describe these in terms of labels, but right now the baseline is the prevalence of zinc inadequacy without any interventions. So just based on diets alone. And then in each year after that, it's how the prevalence, what the prevalence of inadequacy looks like with the zinc intervention, with the fortified wheat flour. Now, because we didn't make any differences across years in say the performance of the wheat flour fortification program or anything like that, as expected, the prevalence of inadequacy is the same across all years in the 10-year time horizon. But if, say, we were scaling up over time or something like that, the values would vary across the years. Let's look at this at the national level. And so this estimates that baseline prevalence of inadequacy is 53% of households have an inadequate supply of zinc to meet the micronutrient requirements of an adult female. And it drops just to 49%. So not a very big change in the prevalence of inadequacy of zinc with wheat flour fortification, which is maybe not surprising given the reach of wheat flour and kind of the low up consumption levels of wheat flour. I guess let's also look at by district just to see variation in effective coverage in the micronutrient inadequacy across districts. So yeah, again, we're kind of comparing baseline to the intervention years. And you can see in some districts, you know, a much bigger impact than in others. So coming back to this Lilongwe and Machinga comparison, dropping from 47% inadequate to 38 in Lilongwe, but just 1 percentage point different in Machinga. And then we can look at effective coverage. So you scroll over to here, and this is the measure that's going to be combined with our estimates of population, so the projected number of households, to when we calculate cost effectiveness. So, you know, at the district level, you can see most districts, the effective percent of households that achieve dietary zinc adequacy as a result of wheat flour fortification is fairly low, with a couple of outliers in the more urban districts of Malawi. And then we can also look at risk of high zinc intakes. I wouldn't be alarmed by these right now. We're still checking numbers. And with household consumption and expenditure survey data, you always have tails of the distribution that are a little bit out of whack. That's just the nature of those HCES data. But just so you know, you will be able to estimate risk of high intakes when you're exploring different fortification levels, etc. Let me look in. Okay, good. Okay. So if we continue now to cost effectiveness, this is where the scripts in the background are going to calculate the 10-year sum of costs and the 10-year sum of households effectively covered. So how many households over our 10-year time horizon change from inadequate zinc to adequate zinc as a result of wheat flour fortification. And then we're going to divide the two to estimate cost effectiveness. So in summary here, zinc fortified wheat flour is going to cost about $6.2 million US per year on average in Malawi. On average, just under 1 million households are effectively covered per year, and the cost per household effectively covered is 6.4. Looking at those numbers just in isolation is maybe not as meaningful as comparing those numbers across other interventions. Sometimes people will compare cost effectiveness to different types of thresholds. So as I mentioned, ability to compare cost effectiveness and cost effectiveness across interventions smoothly in the tool is something that's coming. But for right now, we're just going to kind of do it a little more manually. So I've taken a screenshot previously of these estimates, and we're going to now kind of go through this exercise maybe a little more quickly, but we're going to change the wheat flour fortification standard for zinc. And we're going to try to see how that changes this estimate of cost effectiveness and cost effectiveness. Is zinc fortification more cost effective if we increase the standard? Okay, so now and I apologize for my dogs in the background. So now you can save and close this intervention. So we've walked all the way through from defining the intervention to cost effectiveness, and we can save and close it. If you were going through an intervention and you didn't finish it all in one, you could just save and close and it would save for you and you can come back to it. So I'm going to save and close it and you'll see it's still here for me and I can come back into it and edit it. Which would probably happen, especially if you're going through those costs in very much detail. Now, what I would generally recommend here is, because we want to compare two interventions that are basically the same, except we just want to change one parameter value, the wheat flour fortification level, and maybe a couple of the kind of costs to do that. I would recommend copying the intervention, but actually right now we're checking the calculations there. And just trying to make sure everything is working well with the copying of an intervention. So it would take the intervention you just defined and everything you changed about it and copy it exactly. And then you could work on that and maybe change one or two things to see how cost effectiveness would vary. But we're not totally confident that that's fully working right now. So what we're going to do as an alternative is just create another intervention, and we're going to define it in a very similar way, and then we'll compare cost effectiveness. So you can push create an intervention again. And we're going to make the same choices. We're just going to give it a new name. So we're going to select Malawi. We're looking at our focus micronutrient of zinc, intervention type, large scale food fortification, wheat flour. It's an existing intervention. We're going to select status quo. The choices of the nature of the intervention are also going to expand it to be a little more specific. So here we'd be kind of it's not quite status quo because we're going to be making a change, but I'm going to name this one Malawi wheat flour zinc WHO because I'm going to be changing the zinc fortification level to match the current wheat flour fortification guidelines from the World Health Organization based on wheat flour consumption patterns in Malawi. Okay, and then we'll create that intervention. So now you should see two interventions here. You have the one you previously made and then this new one. And we're going to go in and edit the new one. And it's actually on this very first screen that our main change is going to come. So instead of 80 milligrams per kg, let's change that to 95 milligrams per kg. And you can see that the average fortification level calculations changed accordingly. We're not going to do this right now, but something else you could consider doing is also saying, what if we also invest in improving monitoring and compliance so that, the average fortification level isn't just 63% of the standard, it's, 90% of the standard. You could change that value here and then in the next screen across time. And that would help give you an idea of kind of like, if you change it to 100, it would give you basically an idea of the maximum impact that wheat flour fortification could have on the zinc adequacy of diets. But for right now, let's just change the fortification level from 80 to 95. And then we'll confirm that. On this screen, I think we're just going to leave everything as is. The fortification level has been changed, and we're just going to assume kind of compliance is maintained over every year of the 10-year time horizon. So then we're going to confirm and continue to costs. And if, for example, you accidentally push confirm and continue to effectiveness, you can just use the back button to kind of navigate back to costs. We didn't change kind of compliance with the standard at all. So in terms of industry information, we're going to leave that all as is. Monitoring information, we're also going to leave that all as is. So we're going to confirm and continue. And now in terms of startup and scale up costs, what I think might be good to do is for government industry, there may be some small costs associated with the changeover, but it won't really make a difference. They'll just be buying a different premix. For government, we might want to add some planning costs. So if you scroll down to government related startup and scale up costs and click into planning here, this box will bring up different types of planning costs. And you'll see one is formulation or revision of standards and norms. So say we think it's going to cost about, $10,000 to revise the standards for wheat flour fortification. You can add whatever value you think is appropriate there, and you could add it in this first year or the first year and the second year, and you can see now our total planning costs are $10,000, and we would confirm that. Yeah, and now you can see under the government related startup and scale up costs, we now have a non-zero cost in that first year to account for costs associated with revising the standards. And these graphs on the side, which I failed to point out last time, they were because it was all zero. If multiple activities were non-zero, we would have a kind of a bar, a graph, not a bar graph, a pie chart showing kind of the proportion of each different activity to the total government related startup and scale up costs. So we'll confirm and continue. And the recurring costs are all going to remain the same, but just to confirm, so the cost that really should have changed here is the premix cost. And we just might want to confirm that our fortification level, so if you remember, this was like 5 something previously with zinc at 80 milligrams per kg. You could open your premix cost calculator and just ensure that the fortification level here for zinc, and it is, now it's at 90 milligrams per kg. So the cost per metric ton of wheat flour for the premix has gone up, and the cost per kg of the premix has gone up. Okay, we'll confirm that. So other than the premix cost changing, you as a user could go through and decide if there were any other values that needed to be updated. But right now I'm going to say I'm pretty happy with these costs. The premix cost is really the only recurring cost that's going to change. So I'm going to confirm and continue. And then here is just, as before, the cost summary information, which will be summarized again in the cost effectiveness page. And so we're going to confirm and continue to effectiveness. Here, we aren't going to change anything. We want to leave these all exactly the same. What will be different is the average fortification level that's going to be used in the HCES modeling. So it will provide, per gram of wheat flour consumed, it will provide slightly more zinc. So we'll confirm and continue. Projected numbers household doesn't change. Confirm and continue. Important that we use the same nutrient requirements so that we're comparing apples to apples. And we'll confirm and continue. And then we come to our effectiveness summary. While this loads, I'm going to just look at national level first. Reach and apparent consumption should be exactly the same, right? Because we're not modeling changes in food consumption patterns. We're just modeling changes in the micronutrients added to wheat flour. Let this load. Okay, reach and apparent consumption is the same. I'm going to just scooch over to effective coverage, and we have 5% of households effectively covered here. So it didn't make a huge difference, right? It bumped this up slightly. You'll see in the next slide, and slightly more households are effectively covered. But given wheat flour consumption patterns, in the country, just over half of households are consuming wheat flour, the rest are not. So obviously we're not going to reach those households, and possibly kind of the size of the gap between zinc intake and zinc requirements is just too big to be reached by wheat flour fortification. You can see, yeah, here's at the district level. So some of these numbers have gone up just slightly, but not much. And then we're going to continue to cost effectiveness so that you can see these summary values here. And again, I took a screenshot of it previously, so we'll go back to the presentation and I can show you more clearly one compared to the other, which will be something that will be easy to do for users within the tool soon, but it's just not quite ready. Yeah, so if you remember, the cost per household effectively covered was 6 something previously. So cost effectiveness has improved slightly. So we have about half an hour left in the learning lab. So maybe, and people can continue to play around with this and use the Google Doc that has the case study on it to move through this. But maybe for right now, we should go back to the slideshow and kind of continue on here. Here's this slide just like directly comparing. So this on the top was the estimated cost effectiveness at the current wheat flour standard. And then this was with increasing the wheat flour standard to reflect WHO wheat flour fortification guidelines. So the annual average cost per year went up slightly. The total number of households effectively covered went up slightly, and on balance, cost effectiveness improved slightly. But I think something else we can take from this type of analysis is that, again, this is a testing version of the tool, so we're not using this to make decisions, but this might suggest that meeting the dietary zinc requirements of people in Malawi is zinc, the fortification of wheat flour alone isn't doing that. So Malawi might consider other options like biofortification. And once those options are live in the tool, the user will then be able to also go in and model cost impact and cost effectiveness of, say, zinc agronomic biofortification or zinc beans or some other way to improve the zinc adequacy of diet. So not only is it helping you kind of think about what's going on in terms of the current situation and current diets, but what else needs to be done and what are some options for doing that? Okay, so now that I hope everyone has some familiarity with the cost effectiveness module of the MAPS tool, I want to take a little bit of time to think about how you might use the MAP tool in your own work to answer research or policy questions. And this table just has some examples of the types of research and policy questions that can be answered using the MAPS tool once the full kind of breadth and depth of the interventions and micronutrients are live in the tool. Some questions are relevant for existing intervention programs, some for changes to existing intervention programs like what we just modeled, and others for kind of new or hypothetical interventions. So for example, if your country has released one or more variety of iron beans, you could use the tool to answer the question, what impact is iron beans having on the prevalence of inadequacy of iron in diets in my country? Or if the farmer adoption rate of orange flesh sweet potato has been low, you might want to ask, if we improved farmer adoption of orange flesh sweet potato by some percent, say 30%, by investing in social marketing, nutrition, education, support for vine multiplication, and support to farmers, how would the cost effectiveness of this program change? Or if, for example, you learned via Quick Maps that there is a high prevalence of vitamin A inadequacy in your country, you could then use the tool to ask what population groups might be reached if we introduced oil fortification via vitamin A maize, via vitamin A cassava, and which strategy or combination of strategies would be the most cost effective. So I want to give you just a minute or two to kind of read through these different example questions and then start thinking through whether and what questions relevant to your own work the MAPS tool might be used to help answer. And then in a second, I'm going to ask you to answer via Slido just a few questions about this. So I'm going to give you a second to read through these, and then we'll move to the next slide and ask you to go back to slido.com. I think once you've entered the code, you should be all set and you'll be able to see the next set of questions. Okay, I'm going to activate the questions in Slido. So if you want to go through and just answer those questions, that would be great. Okay, so let's go ahead and take a look at some of the results from those questions. So when we asked what aspects of the MAPS tool do you think might be most useful in your own work for answering research or policy questions, people said effectiveness modeling and cost effectiveness modeling, and as well as cost modeling. So that's nice to hear. Kind of each component of the tool could be useful in your work, and no one said not useful for me. That makes me feel good. What would you be most likely to use the MAPS? Would you be most likely to use the MAPS tool to answer research or policy related questions about, most people said LSFF. Some people said agronomic biofortification and others said biofortification. So I think, and hopefully when agronomic biofortification and biofortification are actually live in the tool, the utility of using the tool for answering questions related to those types of interventions will also be more obvious, but good to see interest in LSFF. And then in terms of, would you be most likely to use the MAPS tool to answer research questions about potential changes to existing interventions was what most people said, new intervention programs and existing intervention programs. And that's helpful feedback for us because we know kind of each different type of intervention program is potentially useful to users. And then we have just ask people to brainstorm policy or research questions that they might use the MAPS tool to help answer. But in addition to these, I just wanted to open the floor to let people talk about, if they wanted, any thoughts they had on how they might use the MAPS tool in their own research or policy context. So if anyone wants to unmute and just kind of describe it, that would be great. But otherwise, it's helpful to have these written out responses as well. And we have some.
Katie, do you want to scroll down a little as well? It
Yep,
looks like there's
sure.
some more there.
Yeah.
But it might help. Other people might get ideas from it.
Yeah.
No, thank you.
Yeah, I did see one or two questions in the chat about subnational level. So kind of by nature, LSFF is a national level program. We can look at impacts subnationally or effectiveness, but when we think about costs, it's harder to think about how we would divide costs subnationally. It's really a program that's implemented at national scale. But for biofortification and agronomic biofortification, there are kind of more opportunities for targeting. So targeting specific regions for biofortification or agronomic biofortification. So that is a functionality that we're thinking about in the tool, is more subnational level estimates of cost effectiveness. It still is a little tricky given that, food products can move around countries via markets. But it's something we're thinking about. So thanks for that comment. And we hope that it's still useful regardless, that effectiveness, kind of the prevalence of inadequacy, reach, and apparent consumption, those can all be looked at a subnational level. Okay. So I think we want to wrap up the session by providing an opportunity for you guys to provide feedback on the tool itself and the session. Any and all feedback, as I said, is very much welcomed and appreciated, as we do want the MAPS tool and sessions like this to be as useful as possible for users like you. So I'll give you the next couple minutes there's a few additional Slido questions where you can provide feedback. I'm not going to share the results of this feedback publicly, so you can feel free to leave anything you want. It can be positive, it can be constructive criticism. I'm not going to share that publicly, but those will all be recorded in Slido anonymously, and then we'll review those all as a team. But after we do that, if we want to come back together, and if anyone has anything they would like to say publicly, or provide some feedback, some suggestions, we would very much welcome that as well. So I'll activate this final poll in Slido where you can just provide some feedback on the MAPS tool and as well as the session. Yeah, while people are finishing up the feedback questions, I do just want to open the floor to any of the people who participated, just to provide any feedback you want orally to us as the MAPS team, how you felt the session went, or how you liked the tool, and any suggestions, anything you want would be helpful for us. It's also great that people are recording some feedback, but if anyone wants to just unmute and let us know, we are also happy to take feedback that way. Okay. People are leaving some nice comments in the chat. We appreciate that. I think that when I click on the next slide, the slide will go inactive, but I can reactivate it just online. So I'm gonna move to the next slide quickly, but as soon as we are done, I'll reopen the feedback questions in Slido so that people can finish leaving feedback if they want. I'll actually wait 1 minute or so more, and then we'll move to the last slide and let people go who are done. But if you have additional feedback, I'll reopen that poll. All right. I want to end the session by saying that if you have additional feedback, again, I'll leave the poll open once we're done, but anytime if you have additional feedback later on, you can leave it directly on the tool by clicking the submit feedback button that you'll find on the right-hand side of each page within the tool. And then you can just type your feedback into this box. Or you can email feedback@micronutrient.support, or you can just email me directly, and my email address is there. Okay, so I think that concludes this learning lab. Thank you all so much for joining, and I hope you felt like it was a productive use of your time, an introduction to economic analyses and the MAPS tool. as I've said, kind of an extended and improved version of the tool and the cost effectiveness module in particular will be available soon. So please do check back at the tool soon if you're interested. Enjoy the rest of your day or afternoon or evening. And again, thanks so much for joining us.
Thank you, Katie, and thank you to the whole MAPS team for putting in so much time to prepare this learning lab for us and share this updated tool. And thanks to all the participants for joining us. I've put a link to the ANH Academy Week program in the chat. We'll have 2 more days of learning labs on Wednesday and Thursday, so I encourage you to join another session if you see one that interests you. And just a reminder, we will post the recording of this session on the ANH Academy website in a few weeks if you want to come back and take a look at these materials again. Have a nice day, everyone.